हेलो एवरीवन, वेलकम टू माय चैनल फिजिक्स ट्रिक्स। आज हम नया टॉपिक स्टार्ट करने वाले हैं एंड दैट इज इलेक्ट्रोस्टैटिक। सो इलेक्ट्रोस्टैटिक्स, in this you have to firstly understand what is charge, right? So charge is there, right? So charge is nothing but it is the property of material by virtue of which it experiences and produces the electric and magnetic effects, right? So we have, if charge at rest, it produces the electric field around it, right? So if charge is at rest, it produces the electric field around it. So only electric field will be there. And if charge is in uniform motion, then it produces the electric field as well as magnetic field around it. So if charge is in uniform motion, u is not equal to 0 but a is equal to 0, in that case it produces the electric field and the magnetic field around it. And if charge is accelerating, in that case it radiates the energy, right? So that means it produces the electromagnetic field around it, right? So it produces the electromagnetic field, right? So if this is the charge, this is the charge, and this is the charge, in this first case charge is at rest, so it will produce the electric field around it. If charge is in uniform motion, it produces the electric field as well as the magnetic field. And if charge is accelerating, it produces the electromagnetic field, along with it electric field also there and the magnetic field also there. So accelerating charge produces three types of field: electromagnetic, electric field and the magnetic field, right? So now we have some properties of a charge. Now what are the properties of a charge? So first one is quantization of a charge. Second one is conservation of a charge. Third one is invariance of a charge. Fourth one is additivity of a charge, right? So firstly we'll see about the quantization of a charge. What is quantization of a charge? Charge on any body is integral multiple of some basic charge, right? Charge on body, that is q, is integral multiple of some basic charge, that is n into e. That basic charge is the charge on electron. So we cannot break the electron and make smaller charge than the electron, right? So this charge q is equal to n into e, we can say, right? Okay, so this n is integer, we can say. And what is integer? It is always 1, 2, 3 and so on. Okay. Now conservation of a charge. What is conservation of charge? Means charge neither be created nor be destroyed, but it can be transferred from one body to other body. That means charge of isolated body is constant. It will not change. Now what is invariance of a charge? Invariance of a charge means what? Charge is independent on velocity. It does not depends on the velocity. We know that mass of a body depends on velocity. That's called as the relativistic mass, and that mass varies with velocity, and that is equal to m naught divided by 1 minus v by c whole square root. Right, this is the relativistic mass, right? And last one we have, and that is the additivity of a charge, and that means charge can be added algebraically. Charge can be added algebraically, right? So this is the additivity of a charge. So if we take one question on this, so if we have, let us suppose, isolated body. This is the isolated body, and if I take inside that 3 bodies, initially on this we have plus 3 coulomb of charge, plus 4 coulomb of charge, and plus 5 coulomb of charge. Finally, if we rearrange this, and if finally this has supposed to be minus 2 coulomb of charge, and this has 9 coulomb of charge, what is the charge on this body? So we know that charge neither be created nor be destroyed, but it can be transferred from one body to other body, right? So if we have, this is A, B, C, charge on body A, B, C will remain constant. So what does that mean? That means whatever the initial charge is there, 3 plus 4 plus 5 is 12 coulomb, must be equal to the final charge, and that is 9 minus 2, 7 plus x. Right, so x must be equal to what is 5 coulomb, right? So this is the answer, right? So we have x is equal to 5 coulomb. So finally this x must be equal to 5 coulomb. So these are the properties of a charge. Okay. Now we have what are the units of a charge. So generally SI unit of a charge is coulomb, and it is represented by capital C letter. Okay, and practical unit of a charge we use practically, that is the practical unit of a charge are, we generally use ampere hour, or farad. Okay, and 1 ampere hour is equal to 3600 coulombs, and 1 Faraday is equal to 96,500 coulombs. So these are the units of a charge, right? So generally we use SI unit of a charge is coulomb, and the practical unit of a charge are ampere hour and Faraday.